Good morning. Today we are going to discuss about how Mosfet acts as a amplifier and as a switch. Before going to that, we will take a small recap on working of Mosfet. Okay. So to understand this, we should have some basic knowledge on how the diode works and how a JFET works. Okay. JFET is a before device to Mosfet junction field effect transistor. Why I am discussing this is always JFET works on reverse bias region. Reverse bias means I hope you have known what is forward and reverse bias in diode. In reverse bias region, P is connected to negative and N is connected to positive. So this is P is connected to negative, P is connected to negative and N is connected to positive. And this N is the N channel. Okay, that's my N channel JFET. Okay, so when we increase this one, what happens? This depletion layer increases. In reverse bias region, depletion layer increases. Hope you know this while studying diode. In diode also, in reverse bias region, depletion layer increases. Depletion layer means there were no charge carriers. As there is no charge carriers, so this channel conductivity is also decreases. Charge carriers depletion means what? It won't allow any current further if the depletion layer width is coming very closer to each other. So there is no channel at all. So you can control the conductivity of this channel by controlling the reverse bias voltage. So this is the principle of JFET. So here two voltages, one is this one, gate to source, another one is drain to source. Drain to source is responsible to allow current to flow in the channel. Gate to source is responsible to control the channel. The same principle we are following in MOSFET also. Remember here we can apply only reverse bias voltage to the gate source region. Okay, but in MOSFET there is a provision of applying both the voltages. We will discuss. So this is metal oxide semiconductor field effect transistor. Hope you are already familiar with this. And this is a metal layer, and this is the channel, and this is why n channel means here we have two n regions and p substrate. If it is a p channel means here we have two p regions and n substrate, and this is the channel, and it acts as a capacitor. This is one plate and this is another plate, and this is some dielectric region. If we increase the voltage here, so if we apply positive voltage, negative is induced. If we apply negative voltage, positive induced. As there is no channel in this case, you have to enhance the channel. So this MOSFET is enhanced MOSFET. Okay, by applying positive, negative is induced. This is already negative, these two are already negative, so if some negative is induced, so there exists a path from here to here, so drain current flows from drain to source, like this, as simple as that. Why metal oxide field transistor means, so this is metal, this is oxide layer, and the NP are the semiconductors. Field effect means, see, here we are applying some voltage. This applying voltage means it's nothing but field. So due to this field effect, the channel width is controlled. Here also due to field effect, this channel width is controlled. That's why field effect transistor. Okay. So coming to types, hope you already know we have two types of MOSFETs in N channel and two types in P channel. Enhanced type and depleted type. And enhanced type means there is no channel before, and we have to enhance the channel by applying reverse bias voltage. That is, gate is positive and drain is negative. Okay, gate positive means what? Actually, this is positive, this is negative means, sorry, this is here we have to apply positive, here we have to apply negative. Means what happened? Some voltage induced. We are not allowed to apply negative here. Hey, if you apply negative, positive is induced. Already this is p type, that is positive layer. Okay, so there is no path between drain to source for the flow of current if you apply a negative voltage here. So we should apply positive voltage here in order to produce negative here and build a channel. So this is called N channel. Whereas in this case, there is already some channel. Okay, even you are applying gate voltage or not, there is some channel. Okay, So this is called on MOSFET and this is called off MOSFET. So before, so what is happening here? I am applying a negative voltage here. Negative voltage means this is negative, this is positive. Positive means what? Already there is a negative channel. We are injecting positives. Okay, means we are depleting the MOSFET. That is why this is called depleted MOSFETs. In other way, if it is completely depleted, the conductivity slowly decreases. Again, if you want to increase the conductivity, you can apply positive here and a negative here, so that it this become positive and here negative induces, means channel builds. Okay, so this is also called a DE MOSFET, depleted and enhanced MOSFET. You can enhance the channel, you can deplete the channel, and you can enhance the same channel. Okay, when enhancement is possible, once you depleted the channel completely, then only you can enhance the channel. Otherwise, at first it is there is some n layer already. You need to enhance at the time of starting. Okay, after depletion only we can enhance the channel by reverse applying the voltage. Okay, so like JFET here also, drain source voltage and gate source voltage, and these are important. These circuit symbols are important. We are using this in amplifier, how to build amplifier. So why there is a break in this means, I hope you already know in your previous lectures. Here there is no channel for enhanced MOSFET, so to show there is no channel we have breaks. Okay, N channel means this is inside, P channel means this should be outside. Okay, so this is D MOSFET, there is already some channel, so this shows, this solid line shows there is already some channel. Okay, characteristics, these are very important. So its characteristics are like this. Why? Because even though we are not applying any gate voltage, VGS is 0 for a D MOSFET, I already told you. Even though we are not applying some voltage, there is a channel. Okay, so there is some current. This current is called drain current, and this point is called IDSS. Okay, this current is called IDSS. We'll discuss what is IDSS, how to obtain the value of IDSS. And if you further reduce the gate voltage also, there is a current but its value is reducing. Okay, and it becomes 0 at one point, means see here, there is already some current even you are not applying any voltage, but what I am doing here, I am applying a negative voltage and positive is inducing, so conductivity is reducing. And if you keep on increasing the negative voltage, the positives are keep on increased, so conductivity is further reduced and become 0 at one point. What voltage I am giving here? Negative voltage to the gate, that's why here shown a negative voltage to the gate, and it becomes 0 at one point. Okay, so even no gate voltage, some current flows from drain to source due to the presence of a channel. So in channel, gate is, sorry, this is VGS positive means channel increases. We are getting a VGS as a negative, so channel conductivity reduces and it becomes 0 at one point. Okay, so N channel means you will get the curve like this. If it's a P channel means oppositely we will get the curve this way. Okay, because for a P channel, what is this? These two are P and this channel is N. So to reduce this channel, we have to inject positive to this, and negatives are induced in the in this one. Okay, so this is P, this is P. Here P should be induced, positive should be induced. Okay, to build the channel. But to reduce this channel, negative should be induced. Negative should be induced means we have to give positive. Okay, so your curve is like this for P channel MOSFET. P channel MOSFET, the arrow is like this, or N channel MOSFET arrow is like this. So for our enhancer type, this is the characteristic.